The breakup would be mechanical engineering, electrical engineering, materials, and that's about it. That's about how deep we go.
Not too components.
The biggest difficulty is getting the car to run. So you can buy battery cells. You have to compose them into a battery box or a battery pack. You have to connect all the different batteries, the battery cells with some interconnects so that they're all either in series or parallel. I forget which system we run. And then you have to make sure that all that power is going through a controller to your motor. And to make all three of these things talk to each other, be wired properly, there's a lot of design involving electric circuitry, there's design involving mechanical toughness of the box, the enclosure itself, how the cells are packed inside, how much room they have to expand or not, and then how much power is delivered when you press the pedal, how much is the computer asking of the battery, and then how much is the motor getting in the end. So there's a lot of programming and there's a lot of circuit building, but at the same time there's also a lot of like mechanical design for our carbon fiber box that we use for our battery,
suspension, and
to mount the motors, to mount the motor controller, it's all mechanical design. The whole chassis is designed in-house, that's mechanical design. The suspension is mechanical design, starting from what design you have, what ratios you're going to have, and what kinetics you're going to have. So if you hit a bump, what's your car going to do if you're steering this much? Which part of the car is going to be taking most of the load under acceleration? The wings, that's fluid dynamics. Yeah, fluid dynamics that comes in with mechanical, but it's also mechanical design when you have to make sure that the wing's not going to break or it's not going to rip off when you're under high load. Yeah.
So do you read?
Yeah, it is. It is, and we've got the captain who's keeping track of all the progress. Then you have two technical directors. What technical directors do is they have past experience with designing these subsystems, and they keep checking in with the sub-team leaders that are actually designing to tell them which direction they should be going for and what is a glaring mistake if they can. Because a lot of the times you can look at things and be like, it's not going to work when you turn your steering wheel.
Yeah.
It's not going to.
Yeah, so you catch it before it becomes like a problem. Yeah.
Exactly. So you have to. It's not that you have to approve the design, but it's up to us to actively keep checking and providing like resources. Go read this book on designing race cars, and then you will find more like knowledgeable. Our job is not to design it. Our job is just to keep checking that everything's progress is on time, and that things will work eventually, and that they're feasible to be, that we can make them.
And I guess also for timelines, like everyone kind of runs on a different timeline for like electrical, like mechanical now.
No,
is it kind of hard?
Okay, so we have pretty solid deadlines for design. For example, our design freeze is sometime in the next week, and after that, no one's allowed to make major design changes that would affect other subsystems. Within your system, if you said that you're going to put a box here, I don't care what you put inside the box as long as you make it work, because that's concerning only your subsystem. But if you say, well, I need a bigger box, then it's going to affect chassis and packaging. That's something that you can't keep on doing all year. So we take the fall semester, September, October, even the summer. September, October to design, November is to finalize all the designs, bring everything together, make sure there's no clashes. And then December for exams, January we start building, January, February, March, April is mostly exams, and then again, May you finish the car and then
race. Okay, oh, cool. And so like the mass adoption of like electric cars.
I'll give you a brilliant example. So some alumni from this team actually graduated school and started their own company making electric snowmobiles. So they're working on their first prototype right now, and since snowmobiles are very recreational, occasional use vehicle, it's easier to have an experimental drivetrain on there rather than something that you drive to work in. So that's why I think electric cars are slowly going to take over, and electric vehicles are slowly going to take over the market when it becomes apparent that they're more efficient, less maintenance, and generally better for the environment because you can reduce emissions.
Lithium, yeah, lithium extraction is pretty bad, I guess. So.
Yeah,
But
there is a concern with the footprint of an electric car's battery. New battery technologies are always coming out. There's something that Tesla worked on for their house solar storage that's pretty exciting. They're also always working on different, so lithium iron phosphate or the metal ion batteries are reaching the end of their, say, researchability. You can't go much further with them. But people are coming up with different battery technologies that function in a completely different electrochemical way, and they don't suffer from the same restrictions. So you can keep developing them more and more, and then you'll see them in the mainstream market maybe like 10, 20 years from now.
Very cool.
Available.
Oh,
The pedal tray that you see over here, it's a complex piece made completely out of carbon fiber and with some metal linkages to reduce the weight. That was also designed and built in-house. Actually, I forgot, the brake pedal is aluminum because we're not allowed to make it carbon fiber. The steering wheel is made out of carbon fiber to keep it light, but the quick disconnect has to be metal because
yeah, you need to,
it has to mesh with a metal surface. The seat, completely made out of carbon fiber, is also a technical marvel because it's so light that it's ridiculous that it still works. Other teams use foam seats, which are much heavier.
Oh wow.
And more cumbersome.
Yeah, I guess you guys really do have a good bit of material.
Yeah,
like,
we
engineering
do.
work to do.
And
yeah.
so this whole box is carbon fiber. That's the whole battery box is carbon fiber. The under tray is carbon fiber. The side wings are carbon fiber. The back wings are carbon fiber. The nose is carbon fiber. There's a lot of carbon fiber on the car.
Fiber, yeah.